All right, here we are with our navigation problems, and we're doing our cross bearing or our 3-bearing fix. So we're getting 3 bearings to 3 different lights, aids to navigation, points on the chart, and we're looking for an intersection here where we can get our position. So in a perfect world, we have what we call a pinwheel, or if we get a triangle, we're just going to pick off the center of that triangle. So flipping over to question number 1, we get 3 bearings to 3 different ATONs, or aids to navigation in this case. And each one of these bearings are in magnetic. So before we do anything, we need to convert these up to true. So I'm just going to take on my scrap sheet of paper here, I'm going to write out T, B, M, D, C, even though I don't need to go down that far because we're starting at magnetic. And our first light is our Cape Henry light. So I'm just going to write Cape Henry right there. Now it was given to us at a 264 degrees magnetic. We have still 11 degrees westerly variation. Now we're going up the table this time. So we're moving up. So in this case, we are actually going to subtract west going up, and we would actually add east if we had any going up the table. So 264 minus 11 is a 253 degrees true. Our next light is our Cape Charles light. So I'm just going to abbreviate this with Cape Charles light. It was given to us at a 354. So I'm going to write 354 degrees magnetic. We have our 11 degrees westerly variation. So 354 minus 11 is 343 degrees true. There we go. And our final light is our Chesapeake light. So I'm just going to read that. Chesapeake light. It was at a 131 degrees magnetic. Again, our 11 degrees westerly variation. And so we take 11 away from 131 and we get a 120 degrees true. So now that we have our 3 bearings converted to true, is the first thing we need to do. We can now take this to our chart. So let me just set this over here. Our first light is our Cape Henry light, which is right here on the charts. I'm going to take our parallel plotter, and reversing what we did earlier, I'm going to measure out my first one, which is a 253. So taking the crosshair above the 6, setting it over top of a meridian, I'm going to start off at 250, and I'm going to count 1, 2, and 3. So I'm at a 253 right there. I'm going to lift. I'm going to roll this back right over top of the Cape Henry light. So there's the light right there. And I'm going to draw this line out and away from it. So there's our first bearing. Next is our Cape Charles light, which after we converted from magnetic to true is 343. So up here is our Cape Charles light. I'm going to go off of this meridian right here, where I'm going to line up with first there is 340, 341, 342, and 343 is right there. So I'm going to lift, roll, right over top of that light. So there's our light, and put my pencil in it and draw this line straight back. And we can see it crossed the other line right there. We need to do our third, which is our Chesapeake light, which after converted from 131, we have a 120 degrees true. I'm going to use this meridian right here. I'm going to line up 1, 2, 0. I'm going to, I'm right on it. Draw my line. And you can see where we have 1, 2, and 3, we have almost a pinwheel there. That's pretty good. So we're going to take and get this position. First, I'm going to measure my latitude. So I do that. I'm going to bring it over here, and we have 36 degrees, 55, 56, 57, just about 58 degrees. So 38.6 degrees, 58 minutes north. So we have 36 degrees, 58 minutes north. And we're going to get our longitude. And we are 75 degrees, 50.8. 75 degrees, 50.8 minutes west. Let's see if we have any answers that come up with that. Now I have a lot to look through here, so let's scroll down to answer delta. 36 degrees, 58 minutes north, longitude 75 degrees, 50.8 minutes west, and that is our position.